Hey everyone, it's Matt here with Nightrun Studio, and so far in this series we've created a lot of the things that make a Metroidvania great, and yet at the end of the day, when you grab all of your spells and battle your enemy and move around in the map and then stop the game, next time you start it up it's just all erased, you're back where you started. So in this video we're going to show how to persist data between sessions. That's right, we are adding a save system. In this first video, we'll show how to serialize your data so that you can save and load simple things like the player's health and position between sessions. In the later videos, we'll show how to save some of the more complex things like inventories and spells gained, and we'll also show how to set up multiple save files. That's where we're headed in this series. Let's get started. Alright, so our very first hurdle is going to be to create a place to actually save our data. Right now we've got data stored in lots of different places, but none of it persists beyond a session. So first of all, I'm just going to head into my folders. Here I'm going to create a new folder. We're going to call this one Session Persistence so that our sessions can persist. And I'm going to create a new monobehavior script here, which we'll just call Save Data. Now this one is not going to need start or update, as it won't actually be a monobehavior. This is just going to be a pure data class that's just going to hold whatever information we want to save in our game. Now the way we're going to be saving things is in the JSON format, and you can't serialize a format to JSON if it isn't in fact serializable. So let's add system.serializable. Now our first piece of data we're going to save is just a public vector2, and that's going to be for the player position. That's literally all we need to do for this script. Now that we've got a place to store all of our data, we need an actual script that can write our data to that location. So let's head back into Unity, create a new monobehavior script, and we'll call this one Save Manager. So let's begin by getting rid of our start and update methods, and we can go ahead and create a public void save game method. Now, this script is going to have some of the more arcane code that we've used so far, as writing data into JSON is not quite the same as anything else we've been doing, but I'll try to explain as we go. So first off, we're going to need to create a save data called save data, and we'll initialize it as a new empty save data file. Now at this point, we're going to need to take our data and turn it into JSON. So let's first of all begin with a string, which we'll just name JSON. And we're going to use the JSON utility. Here we'll take our save data and just put true. Now, once we've converted our save data into a string, we want to actually get a file and write all of that text from that string to a save path on our computer. And the thing we want to write there is that JSON string we just created. Now, while we were writing that, my IDE stealthily added using system.io. You will need to add that as well. Now at this point, I'm just going to put a debug log here saying that Save Manager has saved our game. And then we'll pass along the full save path file, as that's going to make it easier to find this file so we can look at it and make sure it's working properly. Now obviously we've got some red writing here, so we need to come up top and actually make a private string for the save path. Now for where we're going to actually save this, we're just going to create a path where we combine our application's persistent data path along with the name that we want to give this file, which for now we're just going to do save.json. Now we're about ready to run a test here, except that we're never actually calling save game. So let's just quickly add in a start method here. We use the lambda expression to keep it neat and tidy, and just call save game as soon as the game begins. Now if you've been following along with the Metroidvania series, then you probably have a bootstrap scene which holds your player and a lot of your managers. I'm just going to drag that into my hierarchy. Here, we're going to go ahead and create an empty game object, which we'll call save manager. I'm going to drag mine in my bootstrap, as this scene persists between scenes and lasts all the time. I'm then just going to add component and add that save manager we just wrote. I'll remove the bootstrap scene, hit play, and here down on my console you'll see that as soon as the game starts I get my debug. I know that we've called save, and it actually tells me the exact path to which it's saving. At this point we can actually run a test. Now mine was going to my user's library file, and by default on Mac that's hidden, but if I go up to Go and hold down the Option key, you'll see that library finally appears here. I can click on that, and then I just follow the rest of the path. I'm going to go to Application Support. Mine's just under the default company name. And then in here, I'm going to go into my Metroidvania, and you'll see there's a save.json file. You're going to want to open that up. In my case, I'm just going to use text editor. Now inside of here, you can see that it's printed nicely with line breaks, player position, and then a vector2. At the moment, there's no values. It just defaulted to 0, 0, and that's because we haven't actually told it how to save the player's position, so it's just an empty field. Which means we're going to want to head back to Unity and actually find a way to start picking which data we want to save and how to save it. Here, I'm going to create another new mono behavior script. I'm going to call this one iDataPersistence. That I just means that this is going to be an interface, which is a sort of contract between scripts, so that any scripts using this interface will have to include whatever methods we put inside of here. Once again, we can get rid of the mono behavior, and this one's not even going to be a regular class, it's just an interface, which means we won't have a starter update method, and actually we could get rid of using Unity Engine as well. All we want to do here is name the methods that will have to be a part of anything using this interface, which we're going to want to make sure that it always has a save data option, which will pass along a save data file called save data. And we'll also want to make sure that they always have the option to load. So we'll add a load data that's also going to pass along a save data file. That's actually all we need to do to create the interface. Now, first of all, I'm just going to demonstrate what we could do but won't do here is there's a better way. I'll add in my bootstrap, go to my player, and if I open up the player script, I could just start picking scripts that have data we want, adding the iDataPersistence interface up to the top here alongside mono behavior. That said, if we did this, we're going to have to add iDataPersistence into literally dozens of scripts scattered throughout the game, and I'd like to centralize it instead. So, since our player is going to have a significant amount of data that he needs to save, let's create our last script for this video. This will be a new mono behavior script, and we're just going to call this one player persistence. This will probably come as a shocker to you, but I'm going to get rid of the start and update method. And let's go ahead and add the iDataPersistence interface. You'll notice I'm getting an error message right away. And in my IDE, I can actually just right click on here, go to my context actions and implement the missing members, and it will automatically give me the option to add the save and load data. As long as those are both checked, I can click OK, and here we go. It's now just got some empty garbage inside of those two methods, so I could get rid of that. So we've now got the empty structure in order to persist some data, but we need to actually make that data happen. Now this script will be directly on the player, and so it can easily access his transform's position. So let's go into save data, and anytime we save our game, we just want our save data file to know that the player's position is going to be equal to this object's position. Then whenever we load data, we'll do the inverse. We'll just get this object's position, the player's position, and set it equal to whatever save data says the player's position should be. Now then, our save manager is going to need a way to actually send out a message that it's time for player persistence and other persistent objects to run their save data method. So we'll make a private read-only list of iDataPersistence objects, which we'll just call persistence objects. We'll initialize this as a new empty list, and since list belongs to the system.collections.generic namespace, we'll make sure that we add that at the top. Now once we have that list of all the persistent objects in our scene, we can come down to save game, and anytime we save our game, we'll just run a for each loop. Here we'll use the generic var for variable, and just call them object. And so for each object that is in our persistence objects list, we just want to tell that object to run its save data method. Now we do need to make sure to pass along the save data file that we're using. Later this will get more complicated as we add multiple save files, but for now we just have one save data. Here I'll just remove those curly brackets just to keep things a little more compact. You can choose whether you want to do that or not. And now we need to actually make it so that we know what's in this persistence objects list. For this, we're going to make a public void method called register, and it's just going to take in iDataPersistence objects. So essentially, things like our player persistence script can just let this one know that they want to register themselves, and whenever save game is called, the script will then say, hey, it's time to save your data. Now whenever they call that register method, we'll just go to our persistent objects list and add the new persistent object that was just passed in. So how do we actually register our other scripts? Well, for now, let's just head back to player persistence and add a public save manager reference called save manager. Then, in our awake method, we can just tell the save manager that we want to register this, and it'll be registered as soon as the game starts. Whenever we hit save, the save manager will then tell player persistence to run its save data, and it will save the player's position. Back in Unity then, we can go to our player, add the player persistence script, and then make sure that we drag our save manager into that save manager slot. And now when we run our game, as soon as it starts, we get our printout. The difference is that this time, if we go and take a look at our save.json file, we can see that it's actually saving a real position for the player. Alright, so the first and most obvious fix right now is that we don't want to save the game as soon as it starts, but rather when we stop the game. I also want to add a little optimization here. So first of all, let's go into player persistence And rather than have a public reference to the save manager, you can leave that if you like, but if you've been following along in the Metroidvania series, we have a service locator that can do this job a little bit better for us. So here, in our awake method, I'm just going to make sure that the save manager talks to our service locator. You remember that this is just a script that holds a dictionary of scripts and objects, and we have the ability to register scripts here or get them later on. So in awake then, our player persistence will just ask the service locator to get the save manager, and then it'll just save it into file. Now we do want to just change one thing, is we actually don't want to do this in awake, we're going to do it in start. The reason for that is because in the save manager itself, we're going to create an awake method so that the save manager can register itself with the service locator in awake. That way we make sure the save manager is registered before our player persistence tries to look for it. Then we'll get rid of this start method, as we do not want to be saving on start. And instead we're going to come down to the bottom here and just add in the on application quit, which, as the name suggests, runs whenever you quit the app. Here we'll just call save game. And now anytime you turn your project off or quit, it's automatically going to be saving. Now here I just want to show something that could get you into trouble as you're testing. Let's go into our game. I'll run my player over to safety here, stop the game. You'll notice it's saved as soon as we quit. If I open up my JSON file, look inside, you can see that it's actually showing accurate information for my player's position. That said, if I just leave this open, go back into Unity, and run another test, this time going to a different spot in the map, you'll notice that if I come back to the JSON file and open it up, it's still showing the old data. It's not actually that it's not saving, it's just that I haven't refreshed my text editor properly. This one threw me for a little bit when I was first learning how to do this. And so all I want to do is make sure that in between sessions, if you're running a bunch of tests, just make sure that you actually close your text editor in between so that it actually refreshes and you get new values. All right, so we're saving data, but now we need to actually find a way to load that data back in. So let's open up our save manager and come down below the save game method. Here we'll make a public load game method, and it's going to actually work pretty similar to what we did in save, but sort of in reverse. Now before we do anything else, we're just going to do a little defensive check here. We're going to check to see if the file actually exists at our save path. If it does not, note the exclamation mark, we want to return. We can't load a game if one doesn't exist. That said, if there is a file, then we're going to, like above, create a string here, which we'll call JSON. The difference is this time we're going to look at our file and we're going to read all of the text that is found at the save path. At this point, we'll create a save data. Let's just call it data. And that's going to be equal to, and here we'll use the JSON utility once again. This time we're going to write from our JSON. We're going to take that save data file. And the data that's actually going to be written from JSON is that JSON string we just created. At this point, we'll do a for each loop where we loop through all the objects in our persistence objects list. And we'll tell each of the objects that it's now time for them to load their data, and we'll pass along the data file we just created from our JSON. Now we just need to actually call that load game method. Now we could go into our start method and call load game right away, but the problem is our player persistence isn't actually fully initialized until the start method, and so trying to load game while it's still initializing will create problems. So let's come down here and create a private IEnumerator, so a coroutine, which we're just going to call load after init. Now in order to run a coroutine, we just need to add the namespace system.collections. And then in our coroutine, we'll just put yield return null, which will just wait a single frame and then call load game. We'll then go back up to start and make sure that on start we run this coroutine, the load after init, so that we only actually try to load the game a frame after our different persistence objects have had a chance to register themselves. Back in Unity then, we can hit play, run our player over to safety, and then stop the game. And when we hit play again, you'll notice that it does, after a brief little frame stutter, move our player to the correct position. Now that frame stutter will eventually be covered up by our loading screen or fade in, so you don't have to worry too much about that. All right, now that we've got our player saving his position, let's save another piece of data. In this case, I'll show how to save his current health. So the very first thing we'll want to do is head into our save data and create a public integer called player health so that we actually have a place to save this data. Next, we'll head to our player persistence, and here we need a way to actually find out what our health is at. So we'll make a serialized private health reference called health. Now, whenever we save our data, we'll just tell our save data that its player health value should be equal to our health's health value. Now, loading the data gets a little more complicated. In some cases, you might be able to just reverse this, making sure that your health's health value is equal to whatever save data says the player health has. However, ours is a little more complicated because we also have a UI that we need to update. Now, if you take a look in our health script and come on down here, you can notice that anytime our health changes, we have this onHealthChanged event that sends out a message to listeners. So things like our player's UI are listening for changes. If we just straight up set our health, we'll miss that UI call. So let's create a special method here. This will be a public void set health, and it will just take in an integer for the amount we want to set it to. Here, we can set our health value to whatever amount is passed in. We can also make sure that we invoke that event so that our UI and other listeners know that our health has been changed. Now then, in player persistence, we'll just change this so that instead of directly setting our health, we'll just tell health that it needs to run its setHealth method, and then in brackets, make sure that we pass along the value we actually want to set it to, which is our save data's player health. Now, when we get back in Unity, we will need to set this up, so I'm just going to drag in my bootstrap, go to my player, and just make sure that his player persistence knows where to find his health script, which in my case just happens to be on his sprite. Now, I can remove the bootstrap scene. However, if I hit play right now, we'll notice a problem, and that is that my health is initializing at 0. The reason for that is that we do have a save file, and so we're loading our data, but because we didn't have health yet when I created the save file, it's just initializing at 0. So let's go into our save folder and just delete that JSON file so that we can create a new save data. Now then, we can go ahead and play our game, take some damage, and move around, and when we turn off the game, it'll save. When we reload the game, we will in fact get the correct health and position data loaded. All right, that's working pretty nicely, and if your game's really simple, that actually might be all that you need. That said, there's a good chance you've got more complex data. And so in the next video, we're going to show how to save some of our data from the game, like open chests, defeated enemies, and that sort of thing. In videos after that, we'll get into things like saving which scenes we're in, as well as how to have multiple save files. Hope to see you in those videos. Until then, though, this is Matt with Nightrun Studio. Cheers.